Hello. I'm going to talk today about developments in underground coal mining in Europe. More specifically, the introduction of roof bolting, square weight roadways, and joy bolter miner operations into the Polish coal mining industry. On the left there, you can see a map of Poland, and there's a Silesia coal field. On the right-hand side, you can see a photograph of the joy bolter miner. This is a machine that cuts the full width of the roadway. You can see the horizontal cutting drum there. That drum ranges up and down to cut the coal, advance itself forward. The machine has bolting rigs which provide drills to put in roof bolts immediately after the roadway has been cut. So before I talk in detail about the machine, a few words of introduction about myself. That's me on the left-hand side there as a young mining engineer in an English coal mine. And there we're installing a longwall face. That's the canopy of a roof support that we're lowering down onto the face for installation. After working in the UK for a period of time, I moved to South Africa, worked in the mines there, then came back to England to move into equipment manufacturing and joined the company Doughty, which eventually, after a few management buyouts and takeovers, became Komatsu. One of my tasks was the installation of the first Western longwall into Poland in the early 1990s. That's a picture of it there. I was project manager for that job, and that was installed at Staszic coal mine in Poland. I've since then moved on to more of a global role within the company. When I'm not mining coal, I like to ride my bicycle, and there I am at Everest Base Camp in Tibet. That's at the height of 5,200 meters. And there I am riding the last kilometer of road up to the base camp. That's Everest, you can see in the background there. I could spend the next 20 minutes talking about that, but let's go back to mining. This is a typical longwall coal face, and that's the main method of coal extraction in Poland. Machine here is the shearer. These two large drums, they cut the coal, and the whole machine travels up and down this conveyor on which it's mounted, cutting a strip of coal, maybe something like a meter in width, and the shearer moves up and down the face, cutting strips of coal. The roof supports behind it advance the face forward and also hold the roof up and provide protection for the men and the equipment. This is a typical coal mine. You can see the yellow equipment, that's the surface equipment, the drag lines, the drills, the shovels. And we're going to focus in on the underground equipment. This is the continuous miners, load hole dump trucks. And let's travel down to the longwall now. See the longwall operating underground. You see there's the shearer cutting through the coal. This is the block of coal in front of the shearer, and the shearer will travel down the face, cutting about a meter strip of coal, loading it onto the conveyor, and the coal will then taken out on the conveyor and out through the roadways out of the mine. You can see here the roof supports behind the shearer holding up the roof. What happens as the face moves forward, strip by strip, the roof rock is allowed to drop down behind the face in a pile of broken material. Now, it's one thing operating the coal face, but the important thing is getting the equipment into position underground and through the roadways. You can see here, this is a plan of a typical longwall face. These are the trunk roadways, the main roadways of the mine. You can see here, we've blocked out a panel of coal. Maybe that's 250, 300 meters in width, and perhaps 2, 3, 4 kilometers, sometimes even up to 10 kilometers in length. And there's 2 roadways driven up on either side of the panel of coal, and that allows the men and the equipment, ventilation, the fresh air to travel along there. And the longwall equipment there is installed right at the end of that panel and works its way back strip by strip to the main roadways here. That period of time can take maybe 2 or 3 months, sometimes even up to a year. Now, there's thousands of tons of equipment. It's got to be transported down there. It's got to be taken through those roads. The equipment is getting bigger and bigger and strong, heavier duty, and there's always huge pressure on the roadway drivage to keep up in advance with keep up in time with the longwall panels. And that's what we're going to focus on today, is the equipment used to drive these roadways. Traditionally in Poland, they've used road headers for roadway drivage. You can see here the boom of the machine, and at the end of the boom, there's this rotating cutter drum. And the profile of the roadway is cut out by traversing the boom around the profile of the roadway. You see, normally in Poland, they're using arch roadways, and you can see the profile there. After the machine has cut out the face of the roadway, maybe that takes something like 20 minutes or half an hour. They then set these steel girders to the roof. Now, the issue with that is that because there's quite a time gap between setting the steel girder, between cutting the face and setting the steel girders, this allows some movement of the roof above the roadway face. It allows separation of the beds of strata to occur, and you get a little bit of breaking up of the strata and loss of control of the roof. Now, this takes place over a period of time. Now, they set the steel girders, and it looks quite reasonable. But over a period of time, you can get deformation of the roadway because of this. Let's look at the alternative machine. This is the machine that's normally used now in Australia and the US, and in some places in Russia and elsewhere in Europe. It's being found favour. This is the bolter miner. This cuts the full width of the roadway. You see the drum is extended from one side to the other. It's actually got some hydraulic extensions, so it can move out 300 millimetres on either side so that it can be withdrawn through the same roadway that it's cut. So this cutter drum here ranges up and down and cuts out the full section of the roadway just in a matter of minutes compared to the much longer period with the rotator. Behind the drum itself are these shields, and they protect the operators. And there you can see the roof bolts drill holes into the roof and provide, they can put roof bolts into these holes. And the great thing about this is that these bolts are then inserted literally within minutes of the face of the roadway being cut. You see there, look up at the roof, there's a good, robust, solid roof which is held up by the roof bolts and by the mesh. One other thing about the arch profile roadway is that when the Longwall cuts into the roadway, they've got to remove these arches, and that's quite time consuming. There's a certain amount of danger involved in that, and that's being aspect of the process is being removed when you have the square weight roadway. Let's look at the roadways after the machines have done their job. And on the left-hand side, that's the road header roadway, and you can see the arched profile of the road with the arch girders and steel corrugated sheeting in between each girder. And it's a really nice looking floor. It looks a really competent roadway, looks very comfortable, looks very safe. You look over on the right-hand side, you can see the profile of the square weight roadway. The only support is actually by these roof bolts into the strata. So it's the strata itself that's holding the roof up, being held together by the bolts in the form of a reinforced beam. And you might look at that and you might think, well, that roadway on the left looks a lot more secure and a lot more sturdy than the one on the right. But over a period of time, we get deformation of the roadway on the left. As the face cuts back along the roadway and moves towards it, the stresses from the Longwall, because we're breaking the roof up on the Longwall, stresses are thrown forward onto the roadway. And what happens is, because the roof has already been broken up when the roadway comes past, and because the arches have only been set a period of time after that, we're getting loss of control of the roof above the face. That manifests itself by loading into the sides of the road, and that pushes up the floor. Quite often with coal measure strata, you've got weak shales and mudstones in the floor, and there we've got quite a bit of floor heave caused by the pressure from the Longwall face as it advances. And when the Longwall gets even closer, then it has the potential to really deform the roadway. You can see there the steel arches are heavily loaded, moving all over the place. Corrugated sheets are being pushed down into the roadway. And they're actually still using that roadway, because you can see, look, there's the rail tracks in position, the haulage rope there. So that's being still used for transport of men and machinery to the face. Moving over to the right-hand side, even when the Longwall comes close to that bit of roadway, you've still got really good conditions, because we're holding those beds of strata, tying them together nicely, and they've still got a very, very good roof and very robust sides. The roadway looks in really good condition. Let's have a look at the machine that's used to cut this roadway, the bolter miner. There you can see this is the longitudinal horizontal cutter drum that ranges up and down. There's the 4 roof bolts. Those roof bolters can pivot sideways and also forwards, and that gives a really nice range of positions we can get the roof bolts into. Most importantly, because they can pivot forwards, we can get the roof bolts right close up into the coal face, just very, very soon after the face of the roadway has been cut out. You see there's the front shield of the machine, and that the operator would be standing in that position there, operating the roof drills, and he's protected very nicely from any coal that might be falling away from the coal face or from the sides. This is one of my favourite features of the machine. This is the operating platform. This is where the operators will walk up here